Hi, welcome to this lesson on number patterns, arithmetic series. We're going to be looking at the second formula of an arithmetic series. So just as we derived the very first formula and the most general formula for an arithmetic series, there's another useful formula that we can also derive. And this has to do with knowing the first and the last term of the sequence and how many terms there are in the sequence. So if we write out the list of the arithmetic sequence. So remember, the arithmetic sequence is t sub n equals a plus n minus 1 times d, where n is a natural number. So the first term is a, t1. t2 is just a plus the common difference. t3 is a plus 2 times the common difference, all the way up to the last term, tn, which is a plus n minus 1 times the common difference. So we know the first term a, we know the last term, and we're going to call this little l as our last term. So if we know the first and the last term values, and we know how many terms there are in that sequence, then we can rewrite the first arithmetic series formula as follows. So remember, the first arithmetic series formula, the most general one, was this one here. Sn equals n divided by 2 times 2a plus n minus 1 times the common difference. Okay, so what we're going to do is we're going to break apart the inside brackets in a clever way. So 2a we're going to rewrite as a plus that n minus 1 times d. Then we're going to group the a plus n minus 1 times d on its own, and that's going to be added to a. But we know a is the first term, and we know that a plus n minus 1 times d, this is the last term. So I can rewrite this formula as n over 2 into the first term plus the last term. Now that is quite simple looking compared to the first one, right? And this is very useful if we know the following: the first term value a, the number of terms you're adding up n, and the value of the last term. So if you know all three pieces of information, first term, the number of terms in total, and the last term, then you can use this formula, which is exactly the same as the first formula, just written a bit more simply now. All right, where it doesn't take into account the common difference anymore, it just needs to know the first term, the last term, and the number of terms. Okay, and we'll have a look at exploring which of these two arithmetic series formulae can be used in the best position, depending on the context of the question. All right, I'll see you in the next one.